I'm Ranganathan Parthasarathy, Assistant Professor of Structural Engineering at Tennessee State University, and this is the Materials Testing Laboratory in Room 105. In this laboratory, I teach the course Mechanics of Materials Lab, which is ENGR 2131. In this course, the junior students learn the experimental procedures to measure and test the mechanical properties of various materials ranging from brittle to ductile. The first experiment is Introduction to Measurement, where we introduce the vernier calipers and micrometer screw to the students. They understand the principles of measurement of these devices and how to measure the sample dimensions, such as the thickness and width of a sheet type sample and the diameter of a threaded sample using these instruments. The second experiment is using the Instron 5500R universal tester, which can apply up to 10,000 kilogram or 100,000 Newton of load, and it also has an inbuilt extensometer which can be used to measure the deformation. The students load the instrument with a sheet type sample, which we usually use aluminum based alloy, and they obtain the stress strain data for this, from which they calculate various material properties such as elastic modulus, yield stress, fracture strength, modulus of toughness, strain at fracture, and so on. And in this experiment, the students analyze the data using a spreadsheet such as Excel. The second experiment is performed on the Satek Baldwin Universal Tester, which can take about 120,000 pounds, and this equipment has different clamps. For example, the clamps which can be used to perform tensile test on a threaded sample, and the clamps for 3-point bending. So in this third experiment, the students measure the uh, flexural strength or modulus of rupture of wood under 3-point bending, and the deflection is measured with the help of a dial gauge. And from the data collected, the students plot a load versus deformation graph, from which they get the modulus of rupture and the elastic modulus of wood in for this configuration. The students do this experiment in two configurations. So one is on the broad side and one is on the narrow side, in order to understand the effect of the moment of inertia on the mechanical behavior. The fourth experiment is performed using the Phineas-Olsen torsion tester, which can apply up to 10,000 inch-pound, and the sample is affixed between these two clamps, and the twisting moment can be applied manually from here, and can be read off the scale, and the angle of twist can be read off the scale on corresponding to the pendulum. So from this experiment, the students calculate the shear modulus of the material used in this test, and the students analyze the data for the experiment using spreadsheets such as Excel. In the fifth experiment, the students measure the impact toughness of a notched specimen using the SATEC impact tester, which can apply up to 300 foot-pounds. And the, uh, the students use the data to calculate the toughness of the sample. Then in the next experiment, the students use Phineas-Olson hardness tester, which is based on the Rockwell scale, to measure the hardness of different materials such as aluminum. So the scales are a bit more geared towards harder materials, but it can also be used for softer metals and even concrete or polymers. In the next experiment, the students understand the principle of force distribution in trusses, and each member is equipped with a load sensor, and the load sensor can read the internal force in every member when external force is applied. The students perform a manual calculation to calculate the internal force in each member and compare it with the experimental measurement from the force sensors. So, in all of the experiments that we have discussed, the students conduct the experiments in groups of 2 to 3, and for each experiment they are provided with an experimental procedure, then the relevant ASTM manual, and also any spreadsheets which are useful for analysis. And for some of them, the students develop the spreadsheets by themselves. In addition to these experiments for Mechanics of Materials lab, we also do a viscoelasticity experiment using pre-collected data. For this experiment, the students use the relaxation data to calibrate a material model such as Zener solid, and then they use the model to predict experimental results of 3. And in this experiment, the students understand the principles of viscoelasticity. So, in addition to the 5 experiments that we have discussed, for each of these experiments, the students also perform a finite element simulation using Abaqus software. The Abaqus software has about 20 licenses, therefore the students can be seated in the computer lab in room number 227 to run the Abaqus software for finite element simulation. In this way, the students can understand, they can use the finite element simulation to further understand the experimental observations that they get in the lab. For each experiment, the students prepare a lab report according to a template provided to them, and they are graded based on their performance in the lab and the lab reports. This lab has some safety features which we are following. So we have a first aid kit which we are providing, and also the sanitary equipment needed for COVID protection, emergency eye and face wash, and there is no food and drinks allowed in this lab. Thank you.